episode of the CORE10 brought to you by the Uttering Engineers, a podcast created by engineering students for engineering students. My name is Patricia. Today I am joined by Hitain, who some of you already know from a previous episode.
I'm happy to introduce Dr. Dann. Dr. Dann has been a professor who's been teaching engineering 202, engineering statics, for many years now. Dr. Dann, would you like to talk a bit more about what 202 is?
Sure. So 202 or ENGG 202 is a first-year common core course in our engineering program. It is usually offered in the winter term, and it consists usually of 4 sections based on the large number of students who take this course. In terms of logistics, it's usually 3 lectures per week and 1 tutorial. There is no labs, and it is a prerequisite for the civil engineering students who want to go into second year. So in terms of the topic, it's a mechanics course, and statics means we are looking at bodies that are at rest. And that's something that we are really interested in civil engineering. We usually don't want our buildings to move. So all the forces that we apply, we have to make sure there's some sort of balancing each other and are in equilibrium. And that's what this course is about. So usually we start with an overview of what types of forces and loads we have. For example, we have gravitational loads. If you think about a structure, it has a weight, so that self-weight is a force or several forces that need to be considered. We have wind forces. That's usually a horizontal force pushing against an outside wall of a building. We have snow loads. So we have several types of forces. Some are called point loads. They're really acting at a specific point. Others are more like distributed over an area. Others are a volume force that are some sort of occur from the gravitation forces. So once we know these different types of forces, we can then summarize them to all 2 point loads. And then we apply them to our bodies. In engineering, we usually call it more like systems. And if we go civil specific, then it would be like our beams and columns, the structural elements that we use when we build, let's say, a house or something like this. So we apply them, we apply those forces, and then our main objective is we need to balance them. That's why we have a foundation. So we need to determine how much forces, let's say, from the foundation or from the supports need to be activated to some sort of have the overall system in balance. And that's something that you will learn in this course. What are the so-called reaction forces? And once you have that, then the next step is we go into what is happening inside a specific system. So let's say if you're looking at a straight beam that is supported on the left and right, we would like to know at a specific point within the beam, what are the forces that this beam needs to, or the material needs to be able to carry. That is important once you go into second, third, fourth year. We need to determine the size of this beam. So we need to know how much force is in the beam. And that's the first step in statics, to determine internal forces, internal normal force, shear force, bending moment. So these are all forces. You will see the details in the course. And you will be able, through these, through the force equilibrium equations that basically maintains the overall balance of the system, that you can determine those forces at any point in a system. And that is pretty much what this course is about. In terms of the problems that you will solve, you have a so-called 2D or plane problems. So everything is happening in a 2D plane. Those are usually a little bit easier, especially when it comes to the geometry that you need to apply. But you also have 3-dimensional systems. And then it would be a 3D analysis that usually leads a little bit more to vector analysis and a more formal approach of statics.
Thanks for the brief introduction to the course. I had the pleasure to have you before COVID last year. And can you talk more about how long you've taught the course, kind of who you are, a background to kind of yourself, just so that everyone who doesn't know you.
Sure. Let's start with the background. So I grew up in Germany. My undergrad, I got it in civil engineering, and my focus was on structural engineering and geotechnical engineering. So basically, I was focusing on designing concrete structures, steel structures, timber structures, as well as the required foundation. And after I finished my undergrad degree, I came to Canada to do my PhD. I was doing it here in Calgary in the Department of Civil Engineering. And I started working on more like maintenance of structural systems. What happens after the system is designed, it's built, we have to, through the life cycle, we have to maintain it. So every once in a while, we have to go out, we need to inspect the system, we need to see what is the damage that we have, how much damage we have, and then we need to decide, okay, when do we go out and do a repair, or maybe we replace a section. So this was more like my focus on for my PhD. There was also quite a focus on doing this on pipelines, and that brought me closer to the oil and gas sector. I finished my PhD at the end of 2011, and I then was for another 6 months postdoc here in Calgary. And I then moved to Aberdeen in Scotland, and I started working for a major oil and gas company as a pipeline engineer. So I was doing exactly what I was doing as a PhD student. Yeah, pipelines, over time, there's corrosion, there's fatigue, you have all sorts of deterioration going on. And through inspections and maintenance, we try to maintain the safety of the systems and maintain the lifetime of the system. So I was doing that for almost 2 years, and then I came back in 2014, and then I joined the Department of Civil Engineering as an assistant professor. So in terms of teaching, I've been, based on my background, I've been mostly teaching structural related courses. So I started with a 4th-year structural analysis course. So that's basically what you take in the 1st year statics, the equivalent course in year 4. So I was teaching that in my first 2 years. I then moved into 2nd year. I was teaching the follow-up course of statics, which is so-called mechanics of solids, where you go into stresses and strains. I was teaching that for 2 years. I then went back to 4th year teaching an uncertainty course. And for the last 2 to 3 years, I have been in 1st year teaching ENGG 202 statics. So for a first time I taught it as a spring course, and then the following year I was coordinating the full cohort in the winter term, and then I was doing it in 2020 again. So that is my teaching background. In terms of research, I was hired to do research on pipeline integrity and risk assessment, or risk assessment in general on structural and civil engineering structural systems. So again, that comes back to having the system built, having the system in service. We need to maintain the integrity. So then one of the main questions I'm focusing on is right now, when should we go out and inspect? How should we inspect the system? And what type of maintenance? When is the maintenance required? So basically trying to maintain the oil and gas as well as regular infrastructure systems that we have. That's a lot of, in a nutshell, my research.
That will be helpful. I actually have a question coming up later on about your research in particular, but I don't want to ask it now. But I want to keep on track with the talking about 202 as a 1st year foundational course. Aside from to satisfy the requirements from the Canadian Engineering Accreditation Board, in your opinion, is this course an important foundational course for all engineering students, regardless of major, just like, say, 1st year chemistry is? Or do you think this course is just something you have to get through for students who don't want to go into civil engineering?
Right. I'm pretty sure probably a lot of students think like that. That's, oh, I may want to go to electrical engineering. I never worry about statics, so I just have to get through this course. In my opinion, I think Yes, we teach, or our focus is on statics, but what we primarily teach is problem solving. You get a problem which usually is just shown as a picture with some sort of the dimensions of the system. And based on the nature, of course, it's more like related to a mechanical engineering system or a civil engineering system. And but then from that point, getting to your final answer, there's some sort of an approach behind it. And that's the problem solving part. And that's really the true intention behind this course is like, okay, given what you have, how do you slowly take away the things that you don't need, that are not really relevant, to get to the core of the problem, then formulate a mathematical model, and then trying to solve the model. So that's what we try to teach. And so in my opinion, I think this course would be beneficial for all engineering students. But I fully acknowledge in terms of applications, it is really tailored towards the civil engineering and mechanical engineering students.
Yeah, I definitely agree with that statement about problem solving. Because I know in high school there's sort of a common phrase I would hear is physics is about plug and chug. It's just plugging into equations. But doing 202 this semester, I can definitely say it's a lot of problem solving, and I think that part of the course makes it a lot more interesting because it's using the sort of the prior knowledge you have given a new scenario with uh, applications of the principles you've learned, and then trying to find solutions to that. And that's what engineering is all about. So whatever major you go into, I think having those problem solving skills is a must. So I definitely agree with that statement.
Yeah, I agree too. So in my, I don't know in your cohort, Dane, but in my first year cohort, a lot of people, I know that many people don't want to go into civil engineering, and so they're just breezing through the course, just completing each weekly quiz, just getting it done. But I think it's important what Dr. Dann said, that in the basic sense, every engineering course, first year or otherwise, is just a way to problem solve in a kind of different way. It's just practice to problem solving in different situations, basically. And that's, I think, is very important to kind of develop your own style of problem solving, even though you might not even care about the application, but it's just a good practice to doing things differently, even if you're not very comfortable with it. And what Dr. Dann said about you understand that it might not be tailored for everyone because the application is so specific to civil. That is a relief to hear for students who did not get an A in that course. Of course, I might or might not be talking about myself, but thank you for that.
So as we all know, a lot of the courses have changed a lot because of COVID-19. It's been a drastic difference in how students approach lectures and as well as learn. So we just wanted to ask you, Dr. Dann, have you gotten an opportunity to teach 202 with COVID-19, and how has that sort of changed the style of teaching? And do you dislike it or like it, or do you feel like it didn't quite make the adaptation that it needed to?
So I was teaching it the last time in the winter term 2020. And this is when we moved from in-class teaching to online teaching in the middle of the term. So I was the course coordinator, so I was heavily involved in making that transition happening basically over a weekend. As those of you who have taken a class with me, I try to sometimes bring a broomstick or a cable to class, so it's a little bit hands-on. I sometimes ask students to come to the front, join me at the blackboard, and we try to illustrate some of the basic concepts. Of course, when you do this online, and I was then teaching the rest of the term online using Zoom, that was not possible. I tried to do this here in my office at home by illustrating and trying to be some sort of equivalent to what I do in the classroom. But I don't think I got really the quality across that I would have gotten in actually being in a physical classroom on campus. In terms of the content, I don't think there was any change. I don't think there's any change this year. So the same content is covered and has been covered for many, many years. I think the major change is how the lectures are delivered. Of course, it's all online. It may not be as interactive. I've heard other classes that might be a little bit smaller, where there is a lot of discussion going on, because you now also have a chat function where you can write down your question. You don't have to actually ask it personally. So it can really work both ways. And from my experience, I saw that as well. I got less questions when it was in class, but then when I was teaching it online, I saw I had the chat on the right and there was constantly questions coming up. It even came to the point where I was like, I really tried to stay on top of this, but there were too many questions. So if I would have to teach it again, maybe next year, I would like to have, let's say, a teaching assistant with me who some sort of can monitor the chat and some sort of try to reply to questions directly or bring them up and ask on students' behalf. So it's really streamlined and it doesn't distract me as much from observing the chat and teaching the material at the same time. I usually teach all my lectures live and then they will be recorded. So having a good performance is really important. As well as having a lot of input from students, it really makes a lecture come alive. It's we see right away, okay, what are some of the issues that are maybe were not as well explained. So that would really help if we can continue like that. We also see a major change in terms of how we assess the students. I mean, usually we had in-class midterms, we had in-class final exams. Now this is all online. Last year we had it set up on D2L in form of quizzes. These quizzes were some sort of stage, so you had to pass one stage to get to the next. And that also helped that an early mistake was not carried forward through the entire problem. I think overall, that was, as an online exam, it was a very good concept. And I really liked it and I got very good feedback from the students. So there have been definitely some changes. Overall, I personally prefer to teach a lecture on campus in class. I think it really helps to better get a feeling on where the class is, on where on how the material is delivered and how the students receive the material. This is a little bit of a gap that I see right now with online teaching, because I may see 2 or 3 students in front of me, because mostly I have my teaching screen with the notes. So I'm not really seeing the full class. And I think that is really something that where online teaching still needs to be improved, or I would have to improve it when I'm teaching the next class, to think about methods to overcome these challenges.
I agree with engagement during COVID has been so different that even in my courses now, I see that on D2L, there's at least like 78 or 80 questions on the discussion post every week. And I don't know how my profs are handling that. In ILS, because we're doing like an integrated course, that's multiplied by 5 different courses. So every question for 5 different courses is in one D12 discussion box, which makes it so crowded. But there is engagement that I don't think I've ever seen before in a class setting where 70 people or 60 people are raising their hands at once for the same material for the same week. So the engagement, I think, is very positive. But the next question is ENGG 202 a reflection of higher level courses in civil engineering?
Oh, that's a good question. So each of the departments, each of the programs have more or less a course in core in the first year in Common Core. And statics is considered, okay, this is the civil engineering course. And then students go to this course, and yeah, as we said earlier, you deal with, it's basically a mechanics course, you deal with forces, try to find equilibrium and all that. And then students walk out and say, okay, this is civil engineering. And I strongly disagree. I mean, it is a portion of civil engineering, but civil engineering nowadays is much more than that, which is there's a lot of topics, a lot of areas that are not covered that have absolutely nothing to do with statics, and they still belong to civil engineering. So let me maybe briefly give you an overview on how civil engineering is structured at the University of Calgary, or all the different areas we have. So the course that you take, ENGG 202, that is the fundamental course for if you want to become a so-called structural or geotechnical engineer. It's basically if you design buildings, if it's concrete, steel, timber, it doesn't matter. The principles you learn in statics, those are the one that you will see in the higher level courses. So it's truly a foundational course for this discipline. The same if you want to work with soil, if you want to work with foundations, it's also a very foundational course. But aside from that, we have a lot of areas in civil engineering that are not or hardly related to statics. So let's say, for example, transportation engineering. That is an area where you think about road networks, you design railway networks, airport facilities. You don't really worry so much about the actual physical structure, but more like, okay, how much space do you need? How much lanes do you need on the highway? What are the speed limits? How does the, what road profile do you use? So that is an area that is not covered at all in statics, but it is a very important area right now, especially with all the improvements we see from going to electric cars, going to cars that are more like connected and can speak to each other. So that is really an upcoming area. Another one is project management. Every project you have in civil engineering, at some point it needs to be executed. Usually you have to build something. So there you need engineers who need to supervise this. So you need to develop a cost estimation. How much does it cost to build it? You need a schedule for how long it takes. And then you need engineers in the field who supervise all the workers, who make sure it runs smoothly. And that's in essence what project management is about. Also something that you don't see in statics. We then have the areas of water resources and environmental engineering. So water resources, that usually focusing on providing enough fresh water for all our towns and cities to make sure that throughout the entire year, there is enough clean water available. There is never a shortage. They also deal with flood mitigation. So if you have these heavy rainfalls that create floods on the roads and all that, so they are working on that, trying to mitigate those effects. Environmental engineering, also part of it is urban planning, is then what happens with the wastewater. We need an infrastructure system for, okay, once you're done with the water, flows down the drain, well then it needs to be cleaned again, it needs to be put back into the river or wherever it's coming from. So there is an entire infrastructure behind this that you don't see. Most of it is under roads, all the pipes that you need for that. There are some sort of wastewater cleaning facilities that need to be developed, designed, maintained. The same in terms of garbage removal. I mean, that is also something that civil engineer and environmental engineers are looking after. That is, what do we do with all the garbage? How in terms of the different recycling streams, landfill designing those, and so on. So in civil engineering, over the years, it really grew from where it originally came from, let's say 100, 150 years ago, where really the focus was more like the structures type or the structural analysis and project management. It really grew into a very diverse field. Unfortunately, you don't really see all these different areas in your first year.
Yeah, I think that's a very good point I want to emphasize. Because as a first year, when you're trying to decide your major, you often just sort of associate a major with one course. Like, for example, civil engineering is statics, but I just want to emphasize that point that the major is a lot more than just one course. And for example, as Dr. Dan was saying, project management. If you're interested in a different side of civil engineering, but you didn't perhaps like statics as much, I say don't be discouraged. And I think I mentioned this in a previous episode as well, that it's a lot bigger than just one course. So there's a lot of really interesting things that Dr. Dan just talked about, and if those things are interesting, then I think civil engineering, despite if you didn't enjoy 202, might still be a very good option for you. So Dr. Dan, you've worked both in industry and academia. Why did you decide to become a professor? And is there any advice you would like to give to students who might be considering this career path as well?
So after I finished my PhD, for me, it was very clear I would like to go into industry. And at that point, I was convinced I would stay probably in industry for the rest of my life. So what happened is, as I said, I moved to Aberdeen. I started working for an oil and gas company. And I really enjoyed the work. It was very new. You really had projects in front of you. You know, okay, this is a problem that needs to be solved. So it was very different than from doing research, being very on the theoretical side. Now you could really apply your knowledge. And I really enjoyed that part. In my case, it also involved a lot of traveling to different business units across the globe. So I was a lot on the road. And to be honest, a little bit more than I personally liked. And in the first 1.5, 2 years, it was very nice. I mean, you fly around, you're for a few weeks there, then you come back to the main office, you work and so on. And then this new position in civil engineering came up and I applied and I was selected. So then I had to make the decision, okay, what do I do? And I decided to go back to the university, go back to academia and become a professor. So because it gave me a flexibility that I don't, or usually you don't have in a company. Right now I have a flexibility in terms of the research that I do. It's like I can shift it a little bit in this direction or in the other direction. It is quite a mixture of teaching, usually for 2 terms. So we teach most of our courses in fall and the winter term. So then most of the academics were focused just on delivering the courses and the teaching aspect of our job. And then usually in the summertime, that's when we focus more on research. We do a little bit traveling, we go to conferences, we present our work, we write journal papers. And having this variety, having this flexibility, that was ultimately my my goal. I said, okay, it fits better to where I would like to be. And I also always liked working with students. I've been from early years on, I was always a math tutor for many, many years. So I liked working with students. I liked giving lectures. So I thought, okay, after 2 years in industry, industry time was then relatively short. I made the switch back to becoming a professor here in Calgary.
Is there any regrets that come with that decision? Maybe not every day, but sometimes. Are there any kind of?
To be honest, I don't have any regrets. I really enjoy my work. Every day, I'm very happy to start my day. I mean, I've been now in my home office for almost a full year. I really hope soon we can go back and to be in our offices on campus. I always had lots of interactions with my colleagues. There are a lot of discussions. You think about problems. You have meetings. You meet with students. It's a very interactive environment, and that's the part that I'm missing right now a little bit, because right now you really have to schedule a meeting and make sure it's just online. So hopefully soon that will change and we can go back on campus. But I don't have any regrets. I must say it is a very intensive job, like especially when you're in a teaching term. and you're coordinating statics and you're teaching one section. I mean, on those days, I usually get 200 to 300 emails a day. Aside from all the research that is ongoing, supervising grad students, being a member of several committees on campus. So there is a lot of work that is ongoing, and there are definitely times where it's very intense. So, but then you also have the times where it is a bit more relaxed, spring, summer, for example. It's you primarily work with research undergrad students and your research grad students. Then the group is a little bit smaller. It's the email traffic is a little bit less. So having this variety going up in cycles a little bit in terms of the workload, I'm absolutely okay, and I don't have any regrets to do this job. So I'm still looking forward for every day to go to work.
That's great. That's amazing. And for say students who are currently pursuing an engineering degree, who are thinking of maybe the same route of not going into industry, but you know, working in academia, do you have any kind of advice for them?
Okay, so let's start at the undergrad level. If you really think, okay, becoming an academic is your long-term goal, then I would recommend you should start working on this goal early on. It usually means in your undergrad degree or undergrad program, you maybe have 1 or 2 summer terms where you're a research student. So reach out very early to your professors, even if you don't know them. I mean, after the first year, you may know 1 or 2 civil profs, but if you know your area, or you know the reason why you want to go into civil engineering, if you know the area you want to work in or you have interested in, go to the website, see who are the faculty members we have, contact them, talk with them. I mean, nowadays, again, it's more like by email and Zoom meetings. It was a little bit easier a year ago when it was on campus. You could just knock on their door and directly speak with them. But still, make the effort, try to make a connection, see if there's an opportunity for a summer research student. That would be your first step, to get some experience in that area. As you go on, make sure your grades are good, and then you would go into graduate school. So either you would pursue a Master of Science degree in your area, or let's say in some cases, you might be able to switch directly from your undergrad degree into the PhD. That's something that I did. I went directly from my undergrad in Germany into the PhD program here. Not as common, but it is possible. So then you would have to get really eventually your PhD. That is, if you want to become a professor, that is really an absolute must. And while you're at that level, then you need to start publishing papers. You need to get your work out. You need to tell the world, okay, this is what I'm doing. This is where you are the expert. And try to work with a lot of people, go to conferences, present your work, build a network. So after you're done with your PhD, you may want to do a postdoc. And at that point, you then have to make a decision if you want to maybe go for a few years in industry, which I personally highly recommend. I think those 2 years I was in industry was extremely helpful for me to understand, okay, what are the problems that need to be solved in the field? So that is something that I would highly encourage. You can still stay very connected with professors and faculty members. And my advice is during that time, still keep publishing, still keep doing a little bit research if possible. And then with having your PhD, having your industry experience for a few years, then apply for probably assistant professor positions or instructor positions. So right now we have 2 types of positions here at UFC. The professorial positions are those where it's a mixture of research and teaching. That's basically what I do. That teaching is usually fall and the winter term, research primarily in spring and summer. We also have then the instructor stream, though those are full-time so-called teachers or instructors. Their primarily goal is just teaching courses. They may have a little bit research or no research at all. Really depending on your preference, what you prefer. If you really want to be more like just an educator, you might be more suitable for the instructor stream. If you really want to do research, then definitely it's the professorial stream. And then keep applying. In terms of the job location, professorial positions are relatively rare compared to, let's say, civil engineering, a structural position. So you cannot expect that in your hometown that you will find a position as a professor. So you will have to apply nationwide at international levels and see where is an opportunity, where is a good fit, and then find your way to academia.
Yeah, it's such a relief to hear from you, a professor who has done research and who is teaching, that it's okay to kind of cold email profs and kind of put yourself out there even though you don't know anything yet. In first year, I know that me in first year, I was very scared of doing that, and I know a lot of my friends are too, of knocking on profs' doors and cold emailing them. So yeah, but still on the same subject, I want to ask you about one of your listed publications on your UCalgary profile. It's called The Extraordinary in Decision Making, Myth, Apology, or Opportunity. That was the paper that I read because the title, it was one of a few of the title that I understood, because the others were very technical. So that was the paper that I read, and which I'm glad I did because it inspired me to ask you this question. And correct me if I'm wrong, but the paper is categorized under risk assessment and management, and it basically talks about, and I quote, high consequence, low probability events or perfect storms. And in that paper, you presented 3 case studies, 2 of which were the Fukushima nuclear disaster, and then the other was the 2016 Fort McMurray fire. Can you talk about why you co-authored that paper and about your general interest in the idea? Just because I am very intrigued about the possibility of kind of analyzing disasters after they happened, and you did that kind of in the paper.
Yeah. So officially, I do integrity and risk analysis or risk assessment. Now, why do we do risk assessment? It's ultimately to make decisions. And when you, in your personal life from day to day, you make your personal decisions also based on some sort of a qualitative risk assessment. Just for example, if let's say you live in downtown and you need to go on campus and you need to decide in the morning, what time do you get up? So at 8 o'clock, you have your statics class. So what time do you leave the house? Or what time do you get up, have your breakfast, get ready, and then leave? So everyone comes up with a different answer. There is a personal preference in there. Some, they like to be very early. They sit half an hour, 20 minutes early in the classroom, ready to go. And then you have a few that might be late. They might be late for reasons that was not their fault because the train was late. So when we make decisions, we think about, okay, what will happen? What will happen if I, let's say, miss the lecture? No? Or think about if you have to be at an exam at 8 o'clock in the morning. You probably start a little bit earlier because you want to eliminate all those possible uncertainties that you have from the time you get up until you arrive at university and you sit down in the classroom. So my work is, if I want to formalize it, I do formal decision analysis. I really try to draw out a so-called decision tree. What are the options that I have? And then what will happen if, let's say, I make a decision right now to not repair a, let's say, a bridge. There's a chance that something will break. That chance will increase as time goes on. And then, of course, we also have to deal with the consequences. If it breaks, we may have fatalities, we may have injuries, we have high costs to repair it. So this is part of risk assessment is is this decision analysis. And that was some sort of the driver for this paper, because usually in civil engineering, all our systems, they're very safe. So they categorize into the failure, or the probability of failure is very low. But if something happens, if a structure fails, if it partially fails, we often have to deal with very high consequences, even up to fatalities. So we have these rare events that don't happen very often, but when they happen, they are really severe. And this is basically our game that we play in civil engineering. And that's why I'm doing risk analysis to quantify, okay, what is the actual risk? And then based on that, feed this into a formal decision analysis to say, okay, what is the best way forward on what should we do? So it's not just intuitive decision making, oh, maybe let's do this or that. Really try to come up with a mathematical model, use that model, and then it's relatively complex, and then make the decisions or advise on the decisions on how we should go forward. Now, this process can be very formalized, and I've done this in a lot of research papers, but there's also a little bit more to it. Not every model is perfect. We are missing things that are not modeled, that are not included in the model. So as much as we rely on computers and we make this formal decision analysis, we as engineers, we are still able to think through and think about possibilities that are not included, where we say, okay, the computer is telling me this is the best option to go forward, but I may want to deviate for certain reasons. And that was some sort of the driver behind this paper that you mentioned to write it, because you see there is not much, there is no analysis really involved. There's not the hard number crunching that I usually do in the papers. It's more like, it was mostly text. It was mostly bringing in aspects that are not considered in a formal analytical decision analysis that led to these extreme events, like you mentioned 2 or 3 examples, where the analysis, the actual formal and numerical analysis was done very well, but there were extra events, extra uncertainties that were not considered, and they were basically triggering those extreme events in the end that in some of the cases led to a lot of fatalities.
You know, I knew it was a civil engineer's job to make sure that pipes don't burst and bridges don't collapse and buildings don't just fall right out of the sky. But I never knew that there were subject areas dedicated to exactly analyzing kind of this very, very high risk and kind of high fatality happenings that can happen in the world, you know, the way you did. But, you know, I don't really have that much knowledge on what really civil engineers do, so I can't really say anything.
But I mean, if let's say you go to civil engineering and you become a structural designer, so you may design a high-rise building, you decide on the thickness of the columns, you decide the thickness of the slabs, and then you may have several hundred people living in this building for, let's say, 50, 60, or even longer years. So I know you're not really directly confronted with that problem, but in your mind, you should be definitely, as a civil engineer, you should be aware, okay, this is what is going on. If I decide, okay, this is the column we're going to use, that the likelihood of failure is very low, but we also have possibly very high consequences. And that's why once you are out of your undergrad degree, then you become an engineer in training. So you need to build up a little bit more expertise before you become a professional engineer. And then it's probably even more aware, because then you have the signing opportunity to sign off on final designs and say, yes, this is okay. I'm signing for it, that this design is absolutely okay, and now we can build it. And if something happens, hopefully it will never be the case, but then it will come back and say, okay, who signed off on those drawings? Who was the engineer behind this?
Yeah. No, I agree with that. It's about compensating for the things that might even be very low probability, but is important enough to just take the extra measures. And I think you outlined so many of these steps with the Fukushima, with the the height of the walls. It's important to take the extra measures so that things like this don't happen.
Yeah, I think it's an engineer's job to make sure you consider all the possibilities. Um, so before we wrap it up, I just wanted to ask, do you have any final general advice for incoming engineering students or current engineering students?
I have a few. The first one is develop a network as soon as possible. Network with your student. First year, and the same as with the higher years, they can be very intense. You're taking a lot of classes, there are a lot of deadlines, there's a lot of things going on once you're in the middle of the term. Those terms are usually fairly intense in terms of the workload that you have. So having a good network, having friends around you that study with you, it really helps to get through this. It makes sure you don't forget anything, you don't forget deadlines, but you also see you're not alone, you're working together for the same goal. I think that is really important when you come together from high school. Now you're all together in this sometimes massive classrooms. So have a good network. At the same time, and we already touched briefly on that earlier, if you know where you would like to go, is it civil engineering, is it mechanical engineering, or maybe you don't know at all, reach out to the departments, talk to your professors, see what you like. So the earlier you know, okay, this is where I would like to go, the better it is. And as I said, civil engineering is not just statics, it's far more than that. So even if you don't like statics, you may really still love civil engineering, and that's what you want to do. So please make sure to reach out to your students and develop a network, as well as with your instructors. And then the last advice, good time management. You have courses that you really love and you can't get enough. And then you may have other courses where you say, yeah, I'm not really sure about this course. You wish you could remove it and don't have it at all. Unfortunately, that is not possible in first year. So you have to get through all the courses. So make sure those courses you don't like, make sure they don't become a problem. That means you need good time management for every course. Assign a time, have a good schedule. Okay, this is the time that I'm dedicating today for this course to do a certain assignment or quiz or whatever it is. And then make sure you're not really dropping a course. So you work on all courses more or less at the same time. I know that sounds easy in times of when you have midterms and there's a big midterm coming up in one course, you really want to focusing on that. But make sure to have it as much as possible balanced in terms of all the courses you work on, and keep a little bit time to yourself. At some point, all the studying is nice, but work-life balance is very important. So if it's Friday afternoon or evening, stop studying for a while, have a good time with your friends, and then maybe after a day or two, then go back to studying. That's my advice.
That is fantastic advice. All three of those things are definitely things that have helped me a lot in first year. So I'm really glad you mentioned that. Thank you so much. It was a fascinating conversation with you. Patricia, do you have any closing remarks?
Yeah, mostly to kind of plug the Instagram account. But thank you. This concludes our meeting for today. I want to thank again Dr. Dann and my co-host Hatain for the wonderful discussion today, as well as our listeners who are tuning in. If you're a prospective student or haven't taken the course, welcome, and I hope we are giving you more insights on first-year engineering courses as a whole. If you're a student who has taken the course, I hope it was a pleasant walk down memory lane, and I hope you learned something new. If you have any feedback or specific questions about first-year engineering courses, please do not hesitate to reach us through our Instagram at @duringengineers. So yeah, I think that this has been the second episode of the CORE10 series. We will catch you in the next one. Thank you.